Background radiation, an in-depth analysis. Introduction. Background radiation is a ubiquitous and constant presence in our environment, comprising various sources of ionizing radiation that surround us on a daily basis. This form of radiation emanates from natural and human-made sources, contributing to a baseline level of exposure that individuals experience throughout their lives. Understanding the nature, sources, and implications of background radiation is crucial for assessing its potential impact on human health and the environment. Sources of background radiation: natural sources. Cosmic radiation. High-energy particles from space bombard the Earth's atmosphere, producing secondary radiation that reaches the surface. B. Terrestrial radiation. Radioactive elements such as uranium, thorium, and radon are present in the Earth's crust, releasing radiation. Human-made sources. Medical procedures. Diagnostic imaging techniques such as X-rays and computed tomography, CT, scans contribute to human exposure to ionizing radiation. B. Nuclear activities. Nuclear power plants, research facilities, and industrial processes release radiation into the environment. Measurement in units. Background radiation is measured in units such as millisieverts, MSV, or microsieverts, SV, per year. The average annual dose from background radiation varies geographically, with some regions experiencing higher levels due to geological factors. Health implications. While exposure to background radiation is generally low, prolonged exposure or exposure to elevated levels can pose health risks. Ionizing radiation has the potential to damage living tissues and increase the risk of cancer. However, the health effects are often cumulative, and the risk-benefit balance depends on factors such as the duration and intensity of exposure. Regulatory framework. Governments and international organizations have established guidelines and regulations to limit exposure to ionizing radiation. These standards aim to protect both the general public and workers in industries where radiation exposure is prevalent. Regular monitoring and assessment of radiation levels are essential components of these regulatory frameworks. Environmental impact. Background radiation can also impact the environment, particularly in areas with elevated natural radiation levels. Some organisms have adapted to higher radiation levels, while others may show signs of stress or genetic mutations. Understanding these ecological effects is crucial for preserving biodiversity and mitigating potential risks. Conclusion. Background radiation is an intrinsic part of our environment, originating from natural and anthropogenic sources. While it plays a role in shaping the Earth's radiation balance, it is essential to manage and monitor exposure to safeguard human health and the environment. Ongoing research and advancements in technology contribute to our understanding of background radiation, enabling us to develop effective strategies for minimizing risks and ensuring a safe and sustainable coexistence with ionizing radiation.